Now, after this, remember that we've already calculated that value in the last slide. We calculated the value of the force, the value of the force on the soil. We have calculated it. Now we are going to calculate what is the value of the soil bearing capacity. What capacity can this soil muster to resist this load so that the wall is not going to cave in or the wall is not going to collapse. It is very simple. This is the formula you are going to use. And this first thing you are going to do in this formula is to calculate the effective breadth of the wall. Effective breadth of the wall is the breadth minus 2 times eccentricity. You already know that the first one, the eccentricity is 0, the effective breadth is this. This is the formula for calculating the bearing capacity factor. This I just learned this formula. I have not added this formula in the question unless things change. Well, for now, this formula you have to know it. These ones you have to know it. So once you do this, you calculate this. You have been taught bearing capacity calculations before, and from there you would get the bearing capacity of the soil. You divide it with this 81 we calculated for the other one for Rankine. I did not solve for columns for this. You can as well, if you see this thing in the exam, you may not need to solve for columns. So you don't get too worked up. But actually, for comparative purpose, you're supposed to also solve for columns. But if you want to solve for columns, it's the same method you have used to solve this one. So next thing you are going to do, if you do this, you have effectively solved the problem for the two methods. If you do this, you have solved the problem for both when the wall has friction and when the wall does not have friction. Then the last question says, determine the effect of water from the storm. If the water from the storm becomes so high, such that the drainage system of the wall becomes clogged, and if the drainage system of the wall becomes clogged, what will happen is that it will no longer be soil that is going to be adding pressure to the wall, but the water is also going to add hydrostatic pressure, which is this value. Then the second thing that is going to happen, like I said here, is not just going to be the wall only, the water too is going to add hydrostatic pressure, which is this component here. And the second thing that is going to happen is that the wall will no longer have friction. And if the wall does not have friction again, automatically you will know that you don't need to use column method again for your calculation. The only thing you need to use is Rankine, because column method will not work again, because now the wall is completely submerged, the drain system is no longer there. The second thing you are going to note is you will now use effective stress, effective unit weight. Instead of this 17, you are going to minus the 17 from the unit weight of water, because the soil is now submerged. So it's the same formula here, but I added this one to account for the pressure coming from the water. Now this is the unit weight of water. This is the height of the wall. This is the effective unit weight of soil, which is the same unit weight you got before, minus it from 9.8, which is the unit weight of water. Now this is the same formula that we used before, but the only difference in this formula now is that we have now changed the value of the lateral earth force. We've changed it to this parameter, because this is now the new lateral earth force. With this, you can easily go calculate your value, because this is the same thing we did in the last one. That's just the same thing. There's no difference. This one is the value for the the rectangle, this is a value for the triangular aspect, this is a value for the active lateral earth force. So with this same thing we did before, when we want to calculate the moment, the resultant, where is it? Is it going to be acting? Just divide this. Remember that the weight of the wall still remains. This 324 still remains. Why does it remain? Because now, if you want to calculate the weight of the wall, the vertical force only, is going to be contributed by this and this. Whereas the horizontal one is going to be when you want to do the horizontal, you bring this together. So remember that why I did this, why I put this here, is just to explain for you that it's W1 and W2 that account for the vertical. Don't get these things mixed up, please. Now,